Alright, so today I want to talk about types of bonds in chemistry and kind of boil it down and keep it simple to the stuff that you really need to know. So I'm only really going to be talking about the electrons, but each of these bonds does have, each of the types of bonds do have specific properties that associate with them. So first, and they all have to do with electrons. So when thinking about bonds, think about the electrons and what they're doing and how they're moving, and that will tell you what type of bond it is. So ionic bond, this is a transfer of electrons. And so what this means is this is the cornerstone, or the most common example of this is in ACl. So chlorine here, if we look at our periodic table, chlorine sits right here in the halogen and wants to get rid of one electron, or it wants to gain one electron. And sodium over here has one extra electron. If we drew the Bohr model, it would want to get rid of that. So sodium would be really happy to get rid of that one electron and give it to chlorine. And how this bond works is that because the electron has moved, chlorine overall gets a negative charge and sodium takes on a positive charge, because sodium is going to have one extra proton and chlorine is going to have one extra electron because the electron transferred over here. So because this has an overall positive charge and this has an overall negative charge of the entire atom, they're going to be attracted to each other. And so that's an ionic bond. Covalent or molecular bonds are sharing of electrons. I think I spelled sharing wrong. And so in this example, kind of something to think about is oxygen. And so you have O2. So what does that look like? So oxygen has 6 electrons. It would like to gain 2 electrons. That's what that 2 minus means. So what happens is, if we drew a Lewis dot diagram of it, so we draw O, we would draw O, and then O. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh no. I know this works, so. Oh, it does a double bond. Rearrange it like this. So if they arrange like this and form a double bond here, all 4 of these electrons, technically both atoms, have access to it and they're sharing them. And because they're sharing the electrons, they both successfully complete the octet rule. Maybe a diatomic isn't the best example of that. All right. Yeah, it's good. Metallic bonds. For metallic bonds, it's kind of a soup of electrons, or free electrons is what I'm going to call it. And this is why it's so easy. So they're arranged metals. They'd be arranged in a very grid-like or crystalline almost pattern. And in this pattern, the extra electrons that are around kind of just hop between atoms. And as the electrons hop, it just creates this really easy flowing and extra charge in it. And so that's why electronic current moves through metallic bonds really easily, as they have these extra electrons, so one can be replaced and move really quick, and that allows current to flow. So that's kind of metallic bonds. All right, I got to talk about covalent bonds real quick because I kind of mucked that up. But covalent bonds, covalent or molecular bonds, this is the sharing of electrons. So for sharing electrons here, a good example, I'm going to use fluorine. You could use chlorine as well. Just any halogen, because they want one extra electron. That's how I'm going to work it. So if we have fluorine here, and I'm going to be drawing a Lewis dot structure for them. So if you don't know how to draw a Lewis dot structure, go see that video. And so each of fluorine has 7 electrons in its outer thing. So I'm going to draw 1, 2, 3, 4, 5, 6, 7. And on this one, 1, 2, 3, 4, 5, 6, 7. So I drew that way because what's going to happen with these is they're actually going to come and share. Because if this fluorine gave its electron over to fluorine, then this fluorine would want 2, and this fluorine would be happy. So instead what they do is the fluorines will share these 2 electrons, and it's called a double bond. Or, excuse me, they will share those 2 electrons. And so both atoms, this fluorine atom will count it as 8, and this fluorine atom will count it as 8 electrons. And so they're able to share those electrons. And so that's kind of covalent bonding at the basics. Water, some freaky stuff happens. I talk about that in water properties video a while ago. So go check that out.